Okay, so my name is Ryan Benulo. Okay, good. Well, it's only 1:32. It's going to be 9 minutes before 9:41 hits. That's too much to make these people wait, so. Yeah. So I'll just start with, are we recording? Let me know when we are. Are you going to crop all this stuff out? Okay. So my name is Ryan Benulo. I am a 20-year veteran in IT, been doing APIs and security most of my career. I'm also very passionate about integration and high-performance computing, grid computing, stuff like that. I did study mechanical engineering, and so I'm having fun with my Arduino project up here on stage. You see I have a thing. And so this is my thing demo of how to build a remote-controlled jack-o'-lantern. You've got a week to do it. You can go and buy your Spark.io Arduino kit for $40, and it'll ship to you in a couple days. And you can get some LEDs and a speaker and parts from Radio Shack for just a few more dollars and wire them up to a breadboard. It connects wirelessly to your network, and then at that point there's a mobile app called Tinker that you can use to turn the pins on the breadboard on and off. And so I'll just start by giving the warning signal that this thing is about to wake up and become alive. And so I'm literally just pressing a on button on this Tinker app to activate pin number D1, and then I'll light up its nose. Oops. There it is. And there the nose lights up and the buzzer goes off. It is lit, right? Yeah, sure is. So the purpose of this demonstration isn't really to entice you to build wireless jack-o'-lanterns, as that's a gross example of over-engineering a simple solution, which would have been a candle and your voice to spook someone who's coming to your door. The purpose of this demonstration is to really communicate the low cost to entry of connecting the world to the internet. Like I said, it was a less than $100 project. It took me less than 2 days of effort to put this together. And it should raise some concerns, I think, from a security perspective, which is my focus in this talk, on what are we doing to mitigate the risk of these things being hijacked. So let's say that I wasn't just turning on a speaker and I wasn't just turning on a nose, but I was controlling lights in a home or a thermostat, or opening a garage door opener, or anything with a switch that was wired to this thing. So that's really the purpose of this talk, is that I think that the term Internet of Things is a misnomer, and I don't think that everything does belong on the internet, and that's where we need to start talking about enclaves of trust and managing different meshes of things where it's not all being done over the public network, but you start to dedicate private networks that aren't connected to the public internet and use API gateway technologies to control the instructions that are being sent to these devices. And so that's where I'm going to focus on the value of an API gateway in creating trust domains between the controller and the object. So again, what kinds of things are we talking about here? We're talking about a mesh of anything with a switch that could be controlled by a tablet, a web app, a mobile device, maybe a control in your car, now that we've got smart cars that are wired up the network. These are all controllers to the Arduino type objects that are wired to switches that are being turned on and off. And we're not just turning things on and off, we're also connecting these Arduinos and things to sensors. It might be reading temperature, it might be connected to a microphone and sending an audio feed, it might be connected to a camera and sending a video feed. And so we have both privacy concerns as well as loss of control concerns. What if it's connected to a drone or a helicopter? We don't want someone commandeering that and giving it its own flight path when we thought we were controlling it. So these are the concerns that we're addressing in this talk. So what have I done here? What have I built to create this little jack-o'-lantern pumpkin? Effectively, there are two main components. Actually, three if you count the MiFi that's generating the wireless signal here and connecting to the internet. The other two components, as you see on the slide, are a battery, and that is then connected to the USB port of the Arduino, giving it power. There are no batteries, connected to the Arduino, so you have to connect it to some power source. And so the black device is just a standard battery pack, and then on the right-hand side, the small chip at the top of the picture is the actual computer that's got a little bit of memory and processing power, and then 16 pinouts, and that is then plugged into a breadboard, which is what I am using for wiring the LED and the speaker to the controller, so that I didn't have to solder those wires together. And you'll see a couple other parts in there, like a 330 ohm resistor, and you just need to do a little bit of math to determine that you have the right size resistor for the components you're plugging in. This thing is about a 3-volt power source. And so you just need to, calculate your source and draw and to determine you have the right resistance. So that's effectively as simple as it is. And then, the black wires you see there are going to ground. And then the app that I was using on my phone to control those pins where this was wired effectively is called Tinker. It's a mobile app you can get in the App Store. And that's effectively using the Spark.io API to make calls to the chip. So it does have an OAuth token schema, so that's about the extent of the security on it, is that the app gets a token, and at that point the token is used by the chip to determine if this phone is authorized to send it commands. So other than that, there's no other technology involved. So now it begs the question, what more can we do to secure this? Is OAuth enough? What other risks could be are we addressing? Another risk to address is protect the API that's used to flash it. So I'm showing you here the programming interface that allows you to download your own code to the chip, and instead of me sending manual commands with an iPhone app, this thing could be running on autopilot. And so you see some lines there at the bottom where there's a loop occurring, and at first what's happening at the top is I initiate the pinouts. I say we're going to be dealing with 3 pinouts, and I initiate those. And then at the bottom of the code there's a loop, and it's effectively saying wait some time, wait 2 seconds, and then turn on an LED, wait 2 more seconds, then turn on the speaker, then turn on the motor. There's also a motor up in here. Like I said, it could be anything occurring. So effectively the routine that's going on in here is sound the alarm, let them know I'm about to start the engine, turn on the light so they get another visual warning, and then last step, start the engine, and then repeat this in a loop. And now the phone is out of the picture. Right? This thing is just now autonomous. And so that's what you need to protect. You need to protect that your things could be reprogrammed. Now, how do we protect this? I would say the first step to protecting it is put a buffer of protection in between the things and the clients that are trying to use those things. Maybe a client. So what I'm showing here is the concept of a public mesh of things that wants to talk to a private mesh of things, as well as mobile apps that want to use both, as well as web apps that want to use both. And so the API gateway plays that role of mediating this I/O, protecting the REST API, taking the actual API off of the internet and creating a facade to that API. So we're going one level beyond what a normal firewall would be doing, which is typically just opening and closing ports. What we're doing is we're doing additional security. We might be, instead of just using an OAuth token, also requiring an X509 certificate on my client application and doing mutual SSL between my phone and the gateway. That's a bit too heavyweight for this thing. It doesn't have the compute power and the memory to do things like mutual SSL. That's why we're doing tokens only right now on the things. So once you're behind the gateway, then you need to then obviously secure that private mesh with a trusted network, right? Because if that network is compromised, then anyone could talk directly to these Arduinos. They'll have an IP address on the wire. I have a little pro tip on the left-hand side. Let's say that we're dealing with homes, and we're into the connected home. You've seen the commercials with Jeff and his Wink and all that stuff, and we're talking about turning lights on and off. You know about Nest. Well, if you are managing these things remotely, so it's convenient that when you land at the airport, you crank down your air conditioner so it's comfortable when you get home. Well, imagine the scenario where that same thermostat controller is compromised by someone that's interested in you for the wrong reasons, and instead they crank the heat up while you're away, and now you've got a power bill to pay. So these are the things we have to mitigate. So how do we mitigate that? Well, the customer premise equipment in your home, what you have connected to the Wi-Fi router in the cable box, that could also be an API gateway. So now we're getting into the space of the home as the next data center, and the same equipment that we've had in our DMZs in the data center will start to show up in your homes. What does this architecture look like? It's typically a tiered architecture. A buddy of mine that I've got a lot of respect for has started a API company for managing IoT objects. He rebranded it recently as Mesh Blue. It was formerly known as Skynet for obvious reasons. And what I'm showing here in this picture is the actual Skynet.m status API call on the far right-hand side existing behind the API gateway, which is shown in the center of the slide. And then you see a new URL on the upper left-hand side, which I'll demonstrate in just a moment, which is where we're effectively creating an API facade to the actual IoT API controller so that all calls that want to reach that controller are indeed mediated, authenticated, logged, and we generate alerts for any suspicious activity when we see things like brute force attacks occurring, or people doing URL rewriting, or maybe trying to break a cipher. The bottom right-hand side, by the way, is Policy Manager, and there's also a portal, a developer portal for developers to go and register applications to get application IDs and to upload their X509 certificates to authenticate with the gateway using mutual SSL. So now we have a complete system where we're not just dealing with configuring a gateway, we've got a complete system where we're actually starting to build what NIST would call a zero-trust architecture. And it's an important concept to look up, to read up on if you're not familiar with the zero trust architecture concepts. But NIST prescribes the concept of a segmentation gateway and many segmentation gateways in different enclaves that can be managed, and the policies on those gateways can be controlled by a centralized policy manager, what the ex-ACML folks used to call a policy administration point. The gateway would be known as a policy enforcement point. The policy enforcement point integrates with the policy administration point, effectively turning it into a policy decision point, asking the question, the gateway is asking the question, is this transaction allowed? Has that user been blacklisted? Is the token still valid? Have they violated a quota policy? Are they sending too many transactions per second? All of these questions are being answered with that one question, is this allowed now? So that policy manager is playing a very important role to do much more than open a port, close a port. If you want to get a little bit more complicated, we could take this to the next level and talk about tiering gateways together, where we have a tier of gateways that are out in the cloud integrating with another tier of gateways that are in a private data center, such that the private data center is only now accepting connections from the gateways in the cloud, thereby reducing your attack vector by only accepting connections in the internal data center from authenticated calls that have already been filtered in the cloud tier. So this is what I also like to refer to as cloud as a DMZ in front of your actual DMZ. And those red lines indicate that that traffic has been secured with mutual SSL, which should be used if you're concerned with things like Heartbleed and Shellshock and Poodle. Mutual SSL at least gives you the ability to revoke those certificates on the client side on a regular basis, issue new certificates, and do not even open the socket if the parties are not trusting one another, if those certificates are not in the same trusts. So what can you do? You can do things out in the cloud. You can use platform as a service. You can build the entire thing on premise and not do anything on the internet. And you can do a combination of both and build a hybrid environment. Types of policies that you should be concerned with on your gateways: denial of service prevention, malicious code prevention, authentication and authorization policies, antivirus policies. If you see data coming over the wire that might contain a MIME attachment, scan that attachment. And then all sorts of security policies if we want to get out of just OAuth and get into things like SAML and Kerberos and WSSE tokens, and not just do business with REST APIs, but also start integrating with SOAP APIs. Then you might need some WS security policies to do that sort of integration. And then on the right-hand side, quality of service policies are quite important. Cap your bandwidth, cap the number of concurrent connections. Trigger alerts when thresholds are exceeded. Those service level policies will trigger alerts when response time is too slow or you're seeing too many error 500s in 1 hour. And then, cap your throughput in terms of transactions per second that are allowed. Limit it to, a reasonable amount for the use case that you're building. If you're expecting only 100 transactions per second, then put a policy in place that, that actually enforces that. Don't just assume that's all they'll do. We can also use gateways to design complex orchestrations so that we don't have to just call one API, but we can call different APIs based on request parameters. This is effectively a BEPL orchestration flow that the gateway will execute for you, so that now you can do things at the gateway layer in front of many different APIs. Perhaps we're calling both the Spark.io API and the MeshBlue API based on different parameters. The parameter being perhaps the ID of the thing, so that we know which mesh controller to use. And then lastly, monitor the mesh, know who's using it, and effectively look into anomalies. And then lastly, before I get into the demo, manage access to your API with the developer portal, issue application IDs and secrets, allow the option for mutual SSL on the app to connect to the API gateway by giving an option to upload a P12 certificate so that we can verify that the app is trusted, not just because they know this ID and secret, which could be intercepted, but because they still have a valid certificate, which you might want to have expire on a frequent basis. I typically think that client certs should live for 1 month and no more. All right, and then lastly, I guess this is my final slide. Putting it all together, what does the vision look like? I think, again, the vision looks like an internet zero-trust architecture for Internet of Things, where we've got meshes of meshes integrating between gateways and different enclaves and segmentation zones. So now let's do some demonstration. So this is an example of a developer portal that one might build. And I'm having a little bit of fun with it, where I'm showing a routine where we try to get our object to shut down, and effectively it becomes sentient and says, sorry, Dave, I can't do that. I won't shut down. How? All right, so just teasing you a little bit with sci-fi concepts. So what I'm going to, actually before I log in, I'm just going to search for all APIs. And I'm going to demonstrate 2 different IoT APIs and how we are using this developer portal to make it easy for application developers to consume those APIs by generating Swagger documentation automatically in this developer portal. And what I like about our Swagger documentation is that it's actually got scopes on it so that we can hide operations that we don't want the anonymous user to see. So I'll demonstrate this by going into the MeshBlue API. I've got 2 different versions of it. So I'm not logged in. This is just what the anonymous user sees when he's browsing your API docs. So we can go over here, and I'll see that I've got 2 versions. In version 1, I have it status quo, which is how the MeshBlue API works today. The only difference is I changed the URL so it's going through my API gateway, hosted out in the cloud. The documentation for version 1 will show you the Swagger representation of every operation on that API. So we can go in here and expand these operations, and we'll see that this has got a post and a get, and we've got a status operation that's just got a get, my devices, it's just got a get, subscribe. So this is every single operation wide open, and I haven't made any of these privately scoped. In version 2, I made all of the posts and puts and deletes private. And so you won't be able to find any post, puts, or deletes. So this post will not be visible in version 2. And in messages, we might see, devices, here we go. In device, we see we've got a put, a delete, and a post. So in version 2, you'll see that I've hidden those. And I haven't had to change the API in any way. I'm leveraging the capabilities of an API gateway with Swagger documentation and what's, what OAuth uses as scopes to determine what I want to have classified as a public scope, which I think is a relatively low-risk API operation, like just get some data, versus a higher-risk operation, which is posting an instruction, all right? Or maybe putting a command to claim a device, take a device in and out of a mesh. Now, those are higher risk commands that I think should be privately scoped and restricted to only privileged users. And so I'll classify those scopes with a license, and you'll actually have to get a higher grade license in order to use those methods of the API. Now, why am I talking about this? I'm talking about this because my whole point is don't just use the public version of the API. The MeshBlue API is available in GitHub. You can download and build your own API server in your firewall. You don't have to use the cloud version of the API. And as you do that, you'll start to determine which of these operations you want to have be publicly used and privately used, and you'll start locking those higher risk operations down. So what do I mean by Swagger? If you're not familiar with Swagger, when I click on the raw link here, you'll see that we actually generate a JSON representation of the API that is consumable by a code generator that can crank out Objective-C or HTML5 code to talk properly to this URL and knows all the parameters to send to that API call. So now we're taking a lot of human error and typos out of the equation because now the code generator can parse this JSON and know exactly how to talk to it. So we'll see here, it'll parse it and find out that this API is a get with one parameter, UUID. I want to subscribe to the UUID of the thing that I want to manage. I want to subscribe to his alerts and messages. So that's what this API call does. And so your mobile app that you're going to build to subscribe to one of your things will automatically pull that path into the application, and then you can link it, drag and drop that to a field where you type in the UUID inside your app. So that's the value of Swagger from documentation, is that it's not just HTML. It's actually consumable docs that have a one-to-one mapping to what's actually running on the API gateway and on the API server, so that as soon as you release a new version, you update those methods, you deprecate a method, or you change a parameter. As soon as you do that, the documentations get updated. You don't have to go off and hire a documentation person. So that was version 1. So now let's look at the difference between version 1 and version 2. Just wait for this to load. Apologies. All right, so now if I change this version to 2, and I go back and browse again, we'll see that now under devices, I shouldn't see, oh, I do see it. What have I done wrong? I thought I locked those down. So those should be hidden. So let's go find out what I did wrong, and we can actually go through the process to actually hide those things. I might have missed a step. So now I'm logging in as an admin, and I want to modify version 2 to do my scope mapping on those operations. This is a good exercise so we can actually go through the process to make those operations invisible. I just want to check that I turned on the licenses feature. That might have been what I missed. Yeah, so I have licenses turned on. We could also lock the API down so no anonymous users can see it. Only users that are actually logged into the portal can see it. But public with license should be good enough. Make sure I don't have anonymous turned on. Okay, he's turned off. So that's that first step, is just defining the permissions on the API. And then our scope mapping is the magic that should be hiding those docs. So that's where you see here that I've got every operation of the API now mapped to different scopes. So these scopes here, the private scopes, should be invisible to the public user. So that's the next thing I'll check is my license configuration that these scopes are linked to. Maybe I actually have configured my license wrong. So it should be using the sandbox license. And so what we do here, we can see that to create a license, we'll put some terms on a license. So we'll say that this license can only use APIs in the sandbox environment, and it's automatically going to be approved so that a human doesn't have to wait for an admin to approve that request. So this is where I've said that this license is only visible to public scopes. And then the last thing we can do is we can attach a legal agreement. And I've got an example here where I have the Creative Commons share-alike license agreement attached to this license. And so when you try to use this API, you'll have to read and accept that license. So maybe what I'll do is just remove my private license, which might be giving access to this private scopes somehow. Let's just make him so he's used somewhere else. That's the problem. All right, well, I'm not going to fix it right now, but I think we get the point. So I probably am allowing those to be seen because I do have a private license created, and before I didn't have that, so maybe I can deactivate it. Okay, that works, so deactivate worked. So I wonder if I can delete now that I've deactivated. Nope, so he's still in use. All right, so that's a little bit of admin work on configuring scopes and licenses. The other thing that I want to point out is that those same scopes are also linked to OAuth tokens here. So let's just go into our OAuth configuration details on version 2 of the API, and we'll see that we've linked this API and the gateway to an OAuth server so that the tokens that we issued have the same scope mapping as we put on the documentation on what's visible. So after we select the OAuth server that we want to use, by the way, we could also use a third-party OAuth server. So for example here, we can, actually before I make that change, I'll show you the scopes that I've already mapped because that might wipe them out. So on the next page, you'll see here I've done the same mapping where I've got public and private scopes on different operations. And so now if you get a public scope OAuth token and you try to reuse that token with a privately scoped operation, the API gateway will actually give you an error message saying that you don't have the power to do so. And I'll demonstrate that over here. I've linked this to an application. So the process that a developer will typically use is they'll start by saying, I want to build an app to control some IoT objects. And so they'll go through and they'll say, I want to create a new app, and we'll call this, my IoT manager, version 1, HTML5, v1. And they might put a logo to brand it. Leave the app ID and secret blank, and then we'll generate one for that app. And so now we're issuing keys, and so the developer just got keys for an app. Instead of keys for an API, he's getting keys for his app. So now we're doing one more thing, is we're protecting the API keys by not ever issuing API keys. We use the gateway to authenticate each consumer by his app ID and secret instead of just verifying that he knows the key of the API, and thereby putting your API at risk by having one common key that many different consumers are using. By doing it this way, we can now identify different applications and even enforce different policies on them. So by default, you'll start out with an app with no APIs on it. So this is a blank app. It's got no contracts. And if we go to the developer console, we'll see here that there are no APIs even available to use. So the next step is we'll say, well, I want to use version 2 of the MeshBlue API. So I'll search for my APIs, and then I'll ask to create a contract with that. Just forgive my MiFi connection's a little slow. There we go. So I'll find the API I want. I'll read some documentation about it. At that point, I'm convinced this is the one I need, and then I'll begin the process by clicking the Access This API wizard. And what I'm doing now is requesting permission for the gateway to let my app ID that I'll specify in my authorization header do business with this API after I get an OAuth token. So I'm going to say I want to connect it to this new app that I'm building, my IoT manager. I want it in the sandbox environment. I'll ask for the sandbox license. It's automatically approved. That's all I need for now. I'll read and accept the Creative Commons license agreement. And that's all it takes here to effectively identify yourself to the API owner and create a contract that will immediately be enforced by the API gateway, taking a whole lot of management trouble off the hands of the person that's actually concerned with the IoT objects and the IoT API. Now that we've got this contract in place, we can then test it out and see if it works with our developer console. Actually, I have to do one thing, which is put in my OAuth redirect URL for my app. And what you'll eventually be doing is you'll be building a real app, and you won't just be using a developer console. And so this redirect URL would be where your app is hosted. You might have it on some platform as a service environment for HTML5, for example. And so that would be the URL that you would put in there so that our OAuth server knows where to redirect to capture identity and password for the user in order to get his identity verified. Because we're effectively doing two-step authentication here. We're authenticating the application ID, and then we're also authenticating the user. This OAuth server that I'm using here is doing an OpenID integration with Google. So we'll be authenticating the user with a valid Gmail account. So to get our token, we'll just begin, and we'll see all of our operations here. So the privately scoped ones show up, But since I'm using the sandbox license, I won't be able to get a token for those privately scoped operations. I'll only be able to get the one that my license permits. So we'll start by getting our token. So effectively, we first present to the gateway, this is my ID and secret. So that says that you know me and I'm allowed to get tokens. So not anyone can just ask for a token. Only apps that have contracts can ask for tokens. So that's the first step. So we'll do the get token step, and then what's going to happen is we'll get the OAuth dance, and what just happened is it found my Google cookie, it logged me into Gmail, and now it's prompting me to give consent to use my Gmail account to do business with this application that I just built. So I'll give consent. You saw it's giving me public scopes only. And so now I get an access token that will be used to get an authorization header that I'll then use to generate that bearer token to do business with the API via the API gateway. So we've just done a cloud-to-cloud integration through an API gateway. Now, they're still allowing anyone to connect to their API. So I haven't really protected their API here because they're not saying only this gateway can connect to it. So just remember that in order for this to work, the next step, when you want to lock that API server down, let's say we want to lock down your own private Skynet that's in your data center or your colo environment, the next step is to put a firewall rule that says only the MAC address and IP address of this API gateway can connect to the API server. And then second step, do protocol level authentication so that that Skynet server will only accept connections from the gateway that has an X509 certificate on it, and we do client certificate checking and only open up that socket when the certificates are trusted on both sides. That'll prevent someone from going directly to the Skynet server and bypassing the gateway. So the other part of this demo that I wanted to show is using this token with a privately scoped operation. So let's say we want to try to, let's see, is this one going to work? Delete a UUID. That's kind of high risk, right? So we're trying to take a node out of the cluster using a public scope token. So that would be effectively the UUID of a thing that's managed by this API. Run it. So we'll see now the gateway is stopping that transaction, giving a 403, saying that this public scope token doesn't have the power to even use that operation. It hasn't even reached the Skynet server. The gateway circuit breakered it, cut it off. Another thing that I can demonstrate here is I also have quality of service policies on here, and we can see here that eventually we'll get the quality of service policy kick in, and we can prevent the API server from being overloaded by only allowing 10 transactions per minute. So I just said, give me the status of the API 10 times in less than a minute. On number 11, the gateway, again, circuit breakered the connection, doesn't allow the traffic to flow back into the API server, keeping the server up and online and highly available for the other valid users that aren't trying to overload it with load testing traffic or malicious traffic. Yes? So this is, I'm demonstrating here in the developer console. What you would be doing is, I mean, you could even do this in curl or in SOAP UI, or you might be building an HTML5 app with JavaScript. And so you would effectively be generating a get token authorization code call to the OAuth endpoint URL. And you'd be supplying the app ID in that call to the get token. And so in order to get that authorization code to begin the OAuth three-legged dance, you have to effectively make a call with an authorization header that identifies that app ID to the API gateway. So you'd be putting that in JavaScript code. Yeah, so I'm playing the role of the programmer. So the programmer would be going out here to his app. He would show keys, view, and he would effectively copy this just manually. Yeah. So it's just we're issuing a credential. And again, you could take this one step further and you could have him upload a P12 file that he would also put inside the app. And that would do the mutual SSL. So upload a certificate to the key store. The gateway will then only accept connections from clients that have a valid key, as opposed to just clients that know the secret. Another API that I have in here that I wanted to show you was the Spark API. It's very similar to the Mesh Blue API. That's what I was demonstrating with my jack-o'-lantern. So again, the Spark API has a little bit fewer methods. It's equally as simple, though. Let's just go to documentation. So we'll see, again, we've generated Swagger for this. I've pasted some text in here to talk about how they do authentication with OAuth. So they've got their own OAuth server. And so there's a little bit of warning that you'll need an access token to use this. So I haven't done any work here with the Spark API to put my OAuth server on it. I'm just making the point known to the developer that you're going to have to get a token from their OAuth server and use that. All right, so that's effectively not as easy to use here in this environment because I haven't taken the time to adapt it to my OAuth environment. I could be integrating my gateway to their OAuth server, so that might be what I do in version 2. And if we have time, I could probably start that process. I've got 10 minutes left. So let's just go through this, and we'll see in our operations that, again, we can see all the operations. We've got a get, a put, and a get, and I've got all these wide open. There's a post. We're effectively saying, you know, give me all the events, execute a function on a device, give me all the events that match a type of event name, and show me devices by device ID in some variable. So again, a very simple REST API to control Arduinos and IoT devices. So again, so let's just, so how would we go through this process of talking to the Spark.io OAuth server from this API gateway? That's a good exercise to go through. So I'll start by going back to the details page and say I want to add a new version. So this is a typical process. So you might start out with this exact same process in your own environment when you're building your own IoT controllers. Is you'll have a version 1 API that works the way they built it, and then you'll say, well, I want to kind of make changes to it. Maybe I want to change OAuth, maybe I want to use their OAuth, and you'll figure that out. So we'll start by creating a version 2 of it. And maybe we'll say in version 2, I'm going to make it completely private. We're going to turn on licenses. So we see here we're talking to api.spark.io, and we have here now all of the verbs and the URLs to talk to the target. So this is the target configuration. We talk JSON in and out. And then we're just going to create a different URL for version 2. We're going to say that this is going to sit behind the gateway on our cloud. And we won't allow anonymous access in version 2. And I've got now a detailed auditing policy attached, so I'm logging all the traffic that's going to it, and I'll also attach an OAuth security policy, and I'll limit it to the bronze quota, and I'm also going to put an alerting policy on there. And so we'll just save that. Of course, my JavaScript freaks out and I have to reload the page, so let's just do that one more time. So my Firefox has been caching JavaScript, and I have to reload occasionally. Apologies for that. So I'll just quickly do that again. That's all the same. Anonymous, change the URL. So we can really get a feel for just how easy it is to start spinning up new versions of an API that behave a little bit differently than the original. Detailed auditing and OAuth, okay, great. And then bronze quota and alerting policy. Save it. All right, so now we have a version 2, and now if we knew the Spark OAuth server details, we could start to integrate the API gateway with their OAuth server by saying, I don't want to use our OAuth server that I have here already running on my gateway. Instead, I want to talk to another OAuth server that's running outside the gateway. So to do that, we would pick a third-party OAuth server, and we put something in there like HTTPS, api.spark.io/OAuth authorize. That might be the URL. I don't know. I haven't checked. And then the token endpoint would be similar. Token. We would say what type of grant do we want to get from this OAuth server? Are we doing 2-legged? Or are we doing 3-legged? We could ask for both and support both. And again, how are we authenticating the client? Public client, two-way SSL right there, so you could turn that on and make it a little bit more strong, or you could do basic authentication, which is not too difficult to compromise. So again, for the highest strength, you would go with two-way SSL authentication. And then, if you knew the scopes that they issued from their OAuth server, you can map scopes. If you don't know the scopes issued from their OAuth server, you would just leave it with default mapping. And so that's one of the downsides of using a third-party OAuth server. If it's not integrated, then effectively all the APIs operations would just have one scope of public. So you have a little bit of value in having the OAuth server integrated with the gateway because you'll know the scopes. And we do have the ability to integrate with OpenID Connect providers, like Ping Federate has an OpenID Connect provider, and so that's an example where we can actually get the scopes off their OAuth server because we talk the OpenID Connect protocol. It's not just pointing to URLs. So that's effectively the beginning of now integrating your API gateway with an OAuth server that's already in place on an API. And so this is version 2. Again, we're still in the public cloud. In version 3, perhaps you'll be doing something like this. And we'll say in version 3, we're going private on-prem. And we'll change the target to mymesh, myco.net, Spark. Something like that. And you have now your own instance of their API server running behind your firewall, and you're not on the internet at all. So that's my talk. I hope you enjoyed it. Thanks. And you're free to ask any questions if you have any. That's right. That doesn't change at all. Yeah, in version 1 and in version 2, their OAuth server was issuing the tokens. In my Mesh Blue example, my OAuth server was issuing tokens. And I wasn't sending those tokens down to the Mesh Blue API. I was only using them to prevent access to their API at my gateway. So the Mesh Blue API didn't know anything about my OAuth token. They didn't even know that it was happening. It was just from the client side. Okay. Enjoy the rest of your day. Thanks.